Hi, my name is Yasin Zarwal. I will guide you in this lesson, which is a lesson from the CCNP routing and switching course. The first lesson is IP SLA. In general, link redundancy is a good thing, but it can also lead to some network problems. You might want to manually control the route taken by some or all of your network to provide a predictable and deterministic traffic flow. Path control can prevent suboptimal routing, ensure path availability, provide optimized performance for specific applications, provide load sharing among various paths. Using iOS IPSLA. IPSLA is the abbreviation of IP Service Level Agreement, which is a feature that enables a Cisco router or switch to simulate specific types of traffic and send it either to an IP address or to a receiver called a responder. One benefit of using a Cisco device as the responder is that it can add timestamps to help measure latency and jitter. These timestamps take into account the device processing time so that the measurement reflects only network latency. The configuration of a Cisco responder is simple. Use the global command IPSLA responder. IPSLA probes can simulate various types of traffic such as HTTP, FTP, DHCP, UDP jitter, UDP echo, TCP connect, ICMP echo, ICMP path echo, ICMP path jitter, and DNS, and can report statistics such as path jitter. With IPSLA, you can measure network performance and host reachability. This is useful for path control because it enables you to switch to a backup path if network performance on the primary path degrades or if a link failure occurs someplace in the primary path. To use IPSLA for path control, you must first create a monitor session on the probe source device. Second thing, define the probe by specifying traffic type, destination IP address, or any other desired variable such as DSCP value. Schedule the probe beginning and ending times. Define a tracking object that is linked to the monitor session. Link the tracking object to a static route. Now we are going to the lab to see one example. This is the architecture. We have R1, which is the router of the IPSLA. We are going to do all the configuration in R1. We have 3 ISP, Internet Service Provider, ISP1, ISP2, and ISP3. And here I did simulate 3 PCs, PC1, PC2, and PC3. The default gateway of the PCs is 192.168.1.10. The objectives of this lab is ISP1 is the default route for R1. In case there is a failure in the link between R1 and ISP1, then the ISP2 will become the default route for R1. If the link R1 and ISP2 fails, then the ISP3 will become the default route for R1. We do not have any routes here. Now we will go to the configuration of IPSLA. IP address is 40.1.1.2. Timeout in millisecond, which is how long it considers the ping is lost. in our case. Threshold is 700 millisecond, and the frequency is 1 second. The life will forever. You can see life. Now we'll configure the track. Operation 1, we'll choose 1. Here we'll write RTR, which is a response time reporter. We can choose another option, for example, interface, select interface in an interface to track. And one here, and we can select here reachability. Now we are going to add 3 routes. First one, one, second one, here we are going to add 50 as the distance metric. And here 42, which is for the IP of ISP3. I want to see the track. Our configuration is okay, reachability is up. Now we will go to the show IP route to see the routing table. It's okay. Now we are going to simulate a link failure between ISP1 and R1 by shutting down the interface in ISP1, which is the interface serial 00. Okay, we did the shutting down. Now here we can also here in R1 enable the debug to see the change of IP routing. Yes. Now new default route become the default route is 41.1.1.2, and you can check that here by show IP route. Yes. Also we can check that using the trace routes in PC1, for example. We're gonna trace the path going to the cloud. Which is T1.1.10. Let's go in via this path. Okay, now we are going to shut down the interface between ISP2 and the R1. Here the R1, we did the debug, and we will see that the default route will be changed to ISP3, which is the 42.1.1.2. Our new default route becomes 42.1.1.2, and you can see the show IP route, which is 42.1.1.2. I did list here some comments to help you in troubleshooting, which is the show IP SLA configuration 1 is the operation, which verify the IP SLA configuration of operation 1 using this command. Okay, I issue the show IP SLA statistics comment to display the number of success and failures and result of the latest operations, and to view routing table changes as they happen. First, enable the debug IP routing, which I did before. Show track, which lists the tracking objects configuration plus many other details. I hope this is informative for you, and I hope that you subscribe to my channel.